Today we look at fossil fuels. We'll look at coal, oil, and natural gas. We're looking at energy sources for an energy-dependent society. If you look here, today, roughly, we use about 40 to 45% oil. We use about 20-25% of our energy comes from coal, and about 20-25% comes from natural gas. And then we're talking about 5-ish% of hydroelectricity, nuclear, and wind and solar. So we're really looking at fossil fuels. These are the drivers of energy. So that means we need to at least get a basic understanding of hydrocarbon chemistry. That's any chemical compound that consists of only carbon and hydrogen. A chemical compound is a chemical substance consisting of two or more different chemically bonded elements with a fixed ratio. And lastly, we're looking at organic chemistry. This is the scientific study of structure, properties, composition, reactions, and synthesis of organic compounds, dominated by carbon, hydrogen, and oxygen. Where we find carbon, hydrogen, and oxygen, we find the ingredients for organic chemistry. So here we'll start talking about, so where did fossil fuels come from and when did they form? Well, the three major fuels that we'll be focusing on are coal, oil, and natural gas, and all three formed many hundreds of millions of years ago, before the time of dinosaurs, hence the name fossil fuels. The age many, I would even say most, were formed was during the Carboniferous period, and Earth would have looked a lot different than it does today. This was part of the Paleozoic era. Carboniferous gets its name from carbon, the basic element in coal and other fossil fuels. The Carboniferous period occurred from about 360 to 286 million years ago. At the time, the land was covered with swamps filled with huge trees, ferns, and other leafy plants, similar to the picture above. The water in the seas were filled with algae, the green stuff that forms on stagnant pools of water. Algae is actually millions of very small plants. The energy driving all of these processes was the sun, as a result of the chemical bonded energy from photosynthesis. Some deposits of coal can be found during the time of the dinosaurs. For example, thin carbon layers can be found during the late Cretaceous period, about 65 million years ago. And this is the time of T-Rex and most other dinosaurs. But the main deposits of fossil fuels are from the Carboniferous period. As trees and plants died, they sank to the bottoms of the swamps of oceans. They formed layers of spongy material called peat. Over many hundreds of years, the peat was covered by sand and clay and other materials and minerals, which turned into sedimentary rock. More and more rock piled up on more rock, and it weighed more and more. Lots of mores there. It began to press down on the peat, and the peat was squeezed and squeezed until the water came out of it, and eventually, over millions of years, it changed. It turned into coal, oil, or petroleum and natural gas. So here we can look at how coal forms. So coal forms from the dying and accumulation of plant matter before it goes through a physical and chemical transformation. And there are four primary stages. We have the accumulation stage, where plant matter, where peat, in this case, parent matter of coal, accumulates in fresh water, marshes, swamps, and rainforests. Accumulation must exceed the oxidation and biodegradation of the dead matter. Then we have the burial and preservation stage. Subsidence, that's essentially sinking or moving downward, and freshwater preservation and burial are critical for coal formation. The water is eventually squeezed out. Then we have the diagenesis stage. Peat is transformed, it is a form of metamorphosis, into coal through heat and pressure from geochemical processes that take place underground. And so when we look at them all together, we create coal. We create coal from this net accumulation of dead plants that are building up. They're going through heat and temperature change of heat and pressure, and it changes them from this organic looking material into what we would say the primitive or the low grade lignite coal is. And here's what it looks like a little differently. And we're really talking about peat. Peat is not coal, but peat is the parent of lignite, which is your low grade coal. Then you've got bituminous, which is a medium grade, and you have anthracite, which is a very, very high grade coal. It's often called clean coal. And lignite into subbituminous is generally referred to as dirty coal. So we have these huge forests that grew around 300 million years ago, covering most of the earth. The vegetation dies and forms peat. The peat is then compressed between sediment layers that form lignite. Once again, lignite is your early stage coal. Further compression forms bituminous and subbituminous coal. Right? We're just talking heat and pressure, and this is taking place at depth. And then eventually anthracite forms. Now when we look at coal formation, we have to make sure we're realizing that we have the ingredients. We have the organic material. This material was just basking in the sun, and photosynthesis was taking place. It was storing the radiant energy from the sun, and it was stored in these chemical bonds. Well, the energy is still within the bonds, but in the process of heating and compression, right, increase in heat and pressure, it begins to change. It begins to go through a little bit of a pressure difference. So here, if I look here, it has a carbon content of 60 to 71% and a volatile matter content of about 50%, about 53 to 49%. And what's happening here is that we're, over the coalification process, we're squeezing out the gunk and the junk, and we're leaving in the energy, the chemical bonds here. And so what's happening here is you're decreasing as we go from the peat to a primitive lignite coal to subbituminous and to bituminous. We're actually increasing the carbon content while we're decreasing the volatiles. We're getting rid of the junk that doesn't burn, or that leads to a lot of the dirtiness that's defined in the clean anthracite coal. So here we'll look at petroleum. Oil and natural gas together make up petroleum. Petroleum is Latin for rock oil, and it is a fossil fuel, meaning it was made naturally from decaying prehistoric plants and animal remains. It's a mixture of hundreds of different hydrocarbon molecules containing hydrogen and carbon that exists sometimes as a liquid, what we call crude oil, and sometimes as a vapor that we call natural gas. So how petroleum is formed? Oil and natural gas were formed from the remains of prehistoric microscopic plants and animals. That's why they're called fossil fuels. Hundreds of millions of years ago, prehistoric plant and animal remains settled into seas along with sand, silt, and rocks. As the rock built up and the silt settled, layer upon layer piled up in rivers along coastlines and on the sea bottom, trapping the organic matter. Without air, the organic layers could not rot away. Over time, increasing pressure and temperature changed the mud, the sand, and the silt into rock, known as the source rock, and slowly cooked the organic matter into petroleum. Petroleum is held inside rock formations, similar to how a sponge holds water. If I look at this picture here, you can see the fossil fuel reserves. These are what we see in the dark. This would be your oil, or in this case, the crude oil. And they're literally held within different layers that are impermeable or impenetrable, and these are generally shale. So we have these particular scenarios that take place within the earth that are really just changing the process of petroleum, oops, I'm getting crazy here, into crude oil. So once we have crude oil, we then go about separating it. We separate it simply by heating it. Don't overthink this. We pump it from depth, and then we heat it. And the heating then separates it into different components. So you have these different materials that separate out. So if I look at this in terms of what's in a barrel of oil, I get a tremendously wide range of materials that all have different, let's just say, commercial and societal value. That gasoline has a tendency of being the primary amount that we get out of crude oil, but not all. There's jet fuel that's a high octane. We get different types of fuel oils, and we get these different materials that separate out, and all of these have a societal, let's just say, usefulness. So when I look at this picture here, different temperatures are going to separate them out, and you're going to separate them out based on the simplicity of their organic structure. That the petroleum gas is going to rise to the top. It's the simplest structures. We then have gasoline directly beneath it. Then we get kerosene, we get heating oils, and then the bottom here, the highest temperature materials these separate out last. They're a little denser. They're just a little bit more complex in the organic molecular structure. And then lastly, we get this residue down here, and this is what's used for asphalt that we use on our roads. So a very, very resistant residual material from crude oil. And this is called a distillation tower. Distillation is simply separation by heating. And last but never least, we're going to look at natural gas. We can look at this picture here. We see microscopic plants, algae, and bacteria accumulate as they die and sink, and they get covered by sediment. More sediment continues to press and squeeze the organic matter, further changing it and chemically altering the biomatter. So this here would be layers of compressed, right? They're squeezing the material. Parts of the dead matter change to oil mixed with other sediments. And then lastly, what we would see if we were to look beneath the Earth's surface is that oil and gas move upwards through porous sedimentary rock, right, like a sandstone, until they get trapped by what we call a cap rock. And this is an impenetrable or impermeable layer. And what happens is that you can get gas, oil, and water. You get kind of this slurry of material, and you can actually just send down different piping systems and extract precisely what you want. So the cap rock is an impermeable layer. Your oil layer is obviously going to be your liquid material, your liquid petrol fuel. And then you're going to get gases. You're going to get these gas layers. And this gas layer is literally just that, a region in space that's got a lot of pressure, but tremendous amounts of energy stored in this area. So gas and oil are both petrol fuels, but they have a little different way in which they form. And last but never least, I want to go back and make sure we reference how these fossil fuels form. That if I look at this in terms of this picture right here, it should be, here we go, that all of these are forms of just stored sunlight energy. That the sunlight energy that these absorbed over millions and millions of years, and we're talking billions and trillions of organisms, when we burn that fossil fuel, we start a chemical reaction that we're simply just releasing those same energy within the stored bonds, releasing it back into space. So we get heat energy that was once sunlight energy.